Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Excited in this about this area in general, and the conference I think has been really phenomenal so far. And computational social science is really a particularly interesting area. I think it's using kind of computational methods and big data sets is kind of revolutionizing the way people do social sciences. And I'm not going to really say too much more about that. I'll give the speakers more time. And so let's just get started.
That was such a short introduction, and I didn't even get ready to jump on. So but now I'm good. So David Rothschild, I'm an economist at Microsoft Research in New York City, and thank you guys for having me here today. And this is actually what I'm going to be talking about is joint work with Sharad, who is from Stanford, who's actually next speaker, so you can blame him for whatever you don't like. And Adam, who's a grad student at Columbia, as well as a lot of it also is built off of work that we've been doing with Andrew Gelman of Columbia as well. And so it's going to be talking about polling. And the image on the left is an advertisement for Clark Stanley's snake oil, which was sold widely in the United States up to 100 years ago when they determined in a lawsuit that there's neither snake oil in it, nor does it do anything good. And from that, I'll jump into traditional polling. So traditional polling is a $21 billion industry. And it is ripe for disruption by people who understand statistics, and that's where we're jumping into. And what I have up here is something which I pulled off of the website, Pollster. And they take a bunch of polling and they aggregate it and show what's going on. And this was from a month or two ago, and you can see two polls, one done by Gallup, one done by Monmouth University, both done with the best methods that people utilize, random digit dialing. Which means that they try to get a random sample of Americans by calling phone extensions and then supplement that with some randomized hitting of people on the internet through email lists. And what you see is the presidential approval. And you'll see what's interesting is that Gallup had a 50% approval, and Monmouth University at virtually the exact same time over the same type of population had 42%. And what they publish both is a margin of error of plus or minus 3 percentage points. And so this happens all the time, and you probably wonder if there was the margin of error of plus or minus 3 percentage points was true, this would seem rather implausible to happen on a regular basis. The margin of error is generated by assuming that what they do is a simple random sample. So they interview 1,000 or 1,500 people, and they assume that they actually have a perfect, simple random sample of the population, that any single American adult, in this case, is equally likely to have answered the poll. Now, of course, that is not true. No, it's not true. And the reason it's not true is for, oh, sorry, to be clear, they don't actually believe that it's true, but they report margin of errors that are based off a simple random sample.
It's not a simple random sample. They don't calculate a simple random sample. They have internal adjustments.
I'm jumping onto the raking and the weights. Okay, yeah. So on top of the raking weights, to be clear, but what they're not putting into the samples so what they're not putting into the error, to be clear, is coverage error and non-response error. So essentially, coverage error is assuming that the general population is not actually completely in the possibility realm of sample, and non-response error is what happens when people do not answer it equally or not as likely to answer equally. Response rates have fallen to about 5 percentage points, which means that 95% of the people who they attempt to contact don't answer. So, and there's also survey error, which on top of it, survey error, which is basically saying that different polls actually interact with people slightly differently. The question of accuracy is one that's very difficult to think about because there actually is no ground truth. There's no ground truth to the approval rating of the president, so it's hard to think about how that works. So I will agree, and I'm sorry to oversimplify, and I'll talk about how weighting focuses in on it, but you can assume that the margin of error is something that is built off of the random sample plus how they end up weighting in the end, with absolutely dropping off the impact directly of coverage error and non-response error. And I'll talk about how it can and cannot be included in a second. But I don't want to get too much into the weeds on it because it's actually not the main point of today's talk. But I would say that we've done a lot of work just looking at just kind of calculating how the true errors for those things that do have outcomes relate to the simple random sample as a kind of hardest baseline. And essentially looking at the top is what we're looking at is presidential, senatorial, and gubernatorial elections over the past few cycles. We took all the polling that was publicly available off of major websites, and we looked at the root mean square error versus in the dark lines about what actually happened. The dotted lines was if you assumed just even the most perfect simple random samples, just assuming the most perfect random samples. What we see, which is very interesting to us, is that if you compare the outcomes of what you get in the polls to what you'd get if you actually had a random sample, the variance of what you get is actually fairly similar. Let's say it's in the same ballpark of it. What you're really losing out a lot on is essentially bias, wherefore if you look at the polling within a given election where you have a certain number of polling for a given election, the error is not randomized on both sides of it. You generally end up with polls clumped on one side or another. Okay? Most polling, though, you don't have the benefit of having some sort of answer. Those were polls that happened also within the last 3 weeks of the election. Polling also suffers from being somewhat slow, somewhat expensive. So standard polling costs about $1 per response, in a sense, and somewhat inflexible in the fact that if you're working in a system which has telephone as part of the main outcome use case, then you have some sort of inflexibility on how you ask questions and how you jump into questions. I don't want to jump into the weeds of exactly how the margin of errors were determined but all I want to say is that there's a lot of things that are left undone. Because we don't normally have outcomes, you can't separate bias from variance. And also, because there is a lack of full understanding about how non-response and coverage actually changes by questions, it's not something that is easy to incorporate in a systematic way. Okay, the opposite take, the kind of other extreme, is thinking about non-probability polling. So non-probability polling is when, rather than even attempting to get a random sample, you grab samples of convenience. And in 1936, the Literary Digest had a monumental failure. They went out, they sent out 10 million plus postcards to people who were contributors to or subscribed to the Literary Digest or had automobile ownership. And they were amazed when they got back about 2 million of those, and they were pointing heavily towards the eventual loser in the election, Landon versus Roosevelt. And the reason, of course, is that they had a terrible sample, they had very poor coverage, and they had non-response, all of which they didn't account for. But a lot has changed over the years. That actually took several weeks. Now we have internet collections that are fast and flexible, very scalable, and of course there's analytics that can go on top of it. And this distinction between probability and non-probability polling becomes a lot more blurred as you look at the traditional polling in which people attempt to create random samples versus ones in which you don't attempt to create it. There is essentially, you have on one end a theoretical probability, but on the other hand, you have something like the man on the street. And the question comes down to, are we making an artificial binary distinction between these if there is a lot of non-response and coverage error in your ability to try to get the best probabilities? And the analytics is somewhat constrained and has been constrained because of when you try to get a probability sample, you want to demonstrate that the data just works. And so there's certain limitations on how much analytics that people put on top of the data they collect. And so that's what I'm going to jump into today. You can kind of think of it quite simply in some ways as if you think about on the far left, this is going to be your cheapest and your fastest and your worst samples. If you go and you get extreme samples of convenience versus on the far right where you think about standard methods in which you try to get as close to a perfectly representative sample. The census is able to do that with mandatory reporting through the ACS as well. You have places where people go out and they really try to bang on doors and get people to actually respond. RDD is a standard methodology of randomly calling different extensions on telephones. You have companies like YouGov, which are out there subsampling from internet panels that they have created. You have a lot of companies out there that are also willing to make a quota sample, which means that they will simply hit their panel up to certain marginal demographics, generally focusing on, say, gender and age, versus, say, looking at the man on the street. And then, of course, you have the question of analytics. Yes?
So the continuum is arranged according to what?
I would say this is a range of thinking about, generally, when you talk to people in the polling industry, you have a hard cutoff right here, in which they're going to refer to things on the right here as an attempt to make a probability sample, and things on the left here are generally considered non-probability. If you look on this sample, you're going to assume down the sample that as you move to the left, things are going to be faster probably to collect. They're going to be cheaper to collect. And as you move to the right, you're going to have a better sample. You're going to have a sample that is less biased and more representative for the population.
Well, but that's what I'm asking, because you completely ignore the issue of response bias, right? Mandatory does not mean people respond accurately. It's quite well known. For the census, sometimes people give you answers. Having more people not necessarily mean is better. Even it's a probability sample, because people don't necessarily tell you.
Sure. So I mean, on the census, you have the benefit of asking questions that are not based around sentiment. They're based around demographics. There's probably less lying or concern of that. There are many other variables which can be on this continuum. So I don't want to claim to cover all. I would say that on those three variables of kind of cost, time, and essentially sample completeness, you're looking at on this continuum. On this continuum, you're looking at what the basic analytics looks like right now. You have a lot of polls out there that are just showing raw counts. You have essentially where you're matching marginal demographics, which is the main method of what you're using in survey research. And you have kind of more advanced methods that people are now testing out and kind of questioning about looking at regressions and then post-stratification on top of that. There's been a lot of look into understanding this in the research, and I'll point out two recent studies that have been very interesting on this. And the first one is something in which a bunch of researchers went out. They did the same sort of questions, asking about demographics, actually, using both telephone and internet-based probability samples, and then a range of what they referred to as non-probability samples, more of a convenience. What is interesting to this and is thinking about is that they did a simple ranking method on top of it, in which they matched to marginal demographics, which I'll mention on the next few pages. And they look at errors that range from about 3 percentage points to 4 to 5 percentage points. In this paper, they looked at the statistical significance of the difference and said, look, you're getting a much better answer when you use probability sampling. What we're going to be addressing today is whether or not that would be different if they'd used more advanced analytics on top of the data that you see in this section. And second of all, being that for a lot of questions we don't know the raw truth, that we don't know the ground truth, we're going to question whether or not 4 or 5 percentage points is a serious concern, or whether or not this is actually in the same sort of realm of meaning in the long run for most people. Similarly, Pew went out recently and was able to ask the exact same questions, both on the internet and the phones, and they determined a median difference of about 5.5 percentage points. One of the things that I'll focus on also at the end is saying, look, this was a question of not one being right or one being wrong, but them being different, and trying to, again, to determine thinking is 5.5 percentage points a big deal? The number of people first. What? What are the percentage points? Sorry, so this was looking at exact same questions. They had about 50 questions, and they looked to see just basically if you ask the exact same questions on the internet and on the phone, how many percentage points difference were they? So for the average question, the median question, sorry. We're going to look at 4 data sets today. The GSS, which is a very impressively done, expensive survey where they go and repeat to try to find as many people as possible. An RDD poll, one in which was done in quota sampling, where they just stop when they reach certain marginal demographics, and one which is completely opt-in. Kind of some background kind of data on it to think about. There's no, as looking at the continuum, as you were mentioning earlier, on the great basis of kind of money and time. The GSS is something that takes several months to complete, in essence, and it costs about $3 per person per question. Standard RDD, you're looking at about $1 per person per question. In order to do quota sampling on the internet using Pollfish or some similar thing like SurveyMonkey, we're looking at about 10 cents per person per question. And in order to have a fully opt-in sample, which took about 2.5 hours versus several months on the top, we're looking at about 2.5 cents per person per question, which is about a 100-fold difference from what you're looking at in the most extreme situation. So a lot of time difference, a lot of monetary difference in that outcome. Of course, if we compare our most opt-in situation as far as even on the most basic thing, which is not even thinking about the biases, but thinking about just looking at the representation of the sample we get, it's not surprising that it looks very different. If we just allow anyone to come in and answer the question, what we're looking at here is a reasonable geographic divide, a somewhat reasonable divide on ethnicity, much more liberal, more democratic, more higher educated in this case, more males, and a much younger skew. So we have that going against us. So the analytics basically vary depending on what polling company we're talking about. But the basics of what you do in random digit dialing and probability polling is you're going to match marginal demographics. And this has gone a long way. In the last probably 10 years ago, it was based off simply matching, say, the age and gender, maybe race, maybe one or two other things, education, to the census, essentially the most recent census you can find. Now you're going to be looking at a few interactions. They're going to take an iterative weighting process and simply match the marginal demographics. And then if they're looking for a subsample of people, they're simply going to drop people who are not in that subsample. So if you're looking for likely voters, this can be sometimes done with a probability sample, sometimes not. But for the most part, what they're going to do is akin to essentially saying, if they think you're a likely voter, then they're going to keep you. If they don't think you're a likely voter, they're going to drop you. It'd be the same sort of thing if you're looking at a subgroup of demographics. The way that we've been addressing it is to take an approach where we model and we post-stratify. And so essentially, this can be done with a bunch of different types of modeling. Multinomial logit is one way to do it if you're looking at something with multiple sets of answers to any given question. And what we're going to do is we're going to essentially take a few key demographics. We're going to break them up categorically. We are going to then run a simple model of some sort. Some sort of model is going to give us some sort of basic probability that people are going to answer for any given demographic a certain way. And then we're going to post-stratify that to some group of the general population. We become a lot more constrained in some sense on how we post-stratify if we're doing this, right, in this case, trying to be as clear and transparent as possible. But a lot of times we're going to model this part as well. So we can model what we think the likely voter space is going to be, or model what we think the general population is going to be, or model what we think a Microsoft employee looks like, depending on what we're doing. And so simple regression. I'm not going to get into the details of the different choices, and then post-stratification. And this is affectionately mainly known as Mr. P. When we do this, looking at using mechanical Turk data and compare to GSS or Pew, so we've pooled together the answers to 49 different questions that we found on both the GSS and Pew. The GSS is kind of a gold standard. Pew is another major polling company that does RDD. And we have the online survey estimates on the y-axis and the GSS and Pew on the x-axis. What we find is something that looks, well, we're not really sure, right? So it looks decent. It's not like it doesn't blow us away. It also doesn't freak us out completely. And we have about a median difference of about 7 to 8 percentage points. So this is not overwhelming and it's not devastating. But we need to learn a little better. What do we think the accuracy should be? Well, in this case, there's a couple of things that I'll jump into first and say that the mean absolute difference was about 7.4 percentage points using Mr. P. Using traditional polling technique, using the traditional raking, the mean absolute difference was much larger. It was 9.8 percentage points. It's not surprising us too much. We weren't able to match, in this case, GSS and Pew against each other in all the different questions. But we did have 12 questions of this sample in which GSS and Pew had asked the exact same question within a year of each other. And when we did that, the error that they had to each other was actually 8.6 percentage points. What does this mean? This means that even among the gold standard, even among sort of RDD polling and an even better type of polling, asking the exact same question, there's a little bit of time difference, but asking the same question, they actually reported answers that were even slightly further apart than what we were getting from our opt-in sample comparing to Pew and GSS answers. We know that's not the exact same, sorry, please.
Is your data the same 12 questions?
Yeah, so this is a much larger set of questions.
You could pull out 12 questions.
And what I'll do in the next slide actually is show, we did this with both the Pollfish data and with the Mechanical Turk data. On the same 12 questions, what you get is a pretty similar type of thing. We're a little worried in this case that maybe this is not the best representation of GSS versus Pew. We're actually pretty surprised at how far apart it was. So we tried to think a little more of it. There just weren't that many times in which the same type of questions were matched, and it was very easy to do. So we did think about how this would look kind of theoretically, in a sense, if essentially you took a simple random sample and you assume that the GSS and Pew were the actual truth. How far apart would you expect any given set of polls to be if you asked 1,000 people the exact same questions at the same time with two different polling companies? About 3 percentage points. What we're seeing from different works that people have done is somewhere in the realm of 4 and 5 for a lot of the comparisons in which they've done, which include the actual survey error that happens, the actual coverage and non-response error that goes on top of simple random samples. So then it comes and begs the question again, that if we can sit there with the worst opt-in samples and have 7.4 percentage points difference, it's mostly accurate, it's a lot cheaper, and it's a lot faster, and it's up to decision makers to decide if that's close enough for a fraction of the cost and a lot more of the speed. Yeah?
Online polls become more and more prevalent, popular, you will probably need also to account for fraud or someone maliciously entering data into those polls by robots, and then probably raise the cost of doing that. I mean,
yeah, no, that's exactly right. And so basically, for what we've done in trying to build systems to start doing this kind of cheaply and regularly, trying to build reputation systems so that are going into things that have reputation systems, which would try to block against that. Thinking about having login as mandatory for different things so that you can match and try to do basic countermeasures to ensure that people are people and not bots. But yeah, those are things that an opt-in system has to face that a random system would not have to face. Is the fact that you can ping it and you can keep hitting it again and again. When it comes to sub-demographics, when it comes to subgroups, it's very hard to determine whether or not you're good or not, in the sense that we know that the GSS or Pew or any other company's estimates for a detailed kind of subgroup is going to be pretty off. But what we can look at is something which we did previously, which does have a ground truth, which was that we looked at the 2012 election on Xbox. And on Xbox, we asked several 100,000 people, about 350,000 people, who they were going to vote for in the upcoming election. We looked at this right before, about 2 days before the election. This was the Xbox estimates using a few key demographics. And this is what the exit polls showed 2 days later. This is looking at a combination of any subgroup of two demographics, like white males or over 50-year-old women, or over 65-year-old women. And we were pretty comfortable that this was pretty close. This was actually a pretty nice thing for something that's at a very low marginal cost. Yeah. So we were using, actually, this was live, so we were using, at the time, the 2008 voters as the post-stratification space. So this was, to be clear, yeah, so this was done in November of 2012 using people who were on the Xbox, modeling them, their polling, and then matching them out to the 2008 voters.
What is the data point on that, sir?
Sorry?
What is the data point on that?
So what is it? Oh, so the larger circles are how large the demographic group is, and all of these demographic groups are two-dimensional subgroups of race, age, gender, education, and party affiliation. So any double combination of that, any two combination of that. I think the kind of key takeaway from what we're looking at is to say that essentially for the last 80 years or so, it's been a race to try to get the most perfect samples and spending a lot of money and spending a lot of time and a lot of effort. And what we're looking at over the horizon is a race to find the best analytics because it is going to be increasingly difficult to reach those samples regardless of how you try. The cost will continue to rise, the time will continue to rise. And I'll leave you with a thought from Andrew Gelman, who is concerned that the president of the American Association of Buggy Whip Manufacturers, that was his call to arms against the survey research community that was fighting against it. I wouldn't go that far, but I think it is kind of one of those turning points in which basically you need to have a dimensional shift in how they're thinking about it, moving away from this question of sampling, which they're holding on to, and pushing towards more intense analytics. So thank you.
We have time for some questions.
Jelly?
Just one suggestion, then one question.
Yeah.
The suggestion is you start by putting everything sort of against the simple random sample. I don't think that's very effective. First that you basically, for anybody who has a knowledge in that field, will see that you are trying to beat the dead horse. The literature has gone far above all the simple random sample, stratified samples, non-response bias. These are all well understood. But I think your point is well made. The point is, like in practice, people probably still thinking about simple random sampling, doing it as simple random sampling. But I think in terms of the way you're trying to move the research forward, you probably shouldn't really think that you are just improving upon simple random sampling, or even use that as the benchmark.
No, I take it's totally legitimate that I don't want to be looking like I'm using a false baseline, and I understand that they've moved past it. I do think, though, when you look at, and I should make it more clear, though, but when you look at what they're publicly kind of saying as far as theory goes, yeah, exactly, that's what they're trying to do.
But the more serious question here is really, I agree with you, it's not a probability versus non-probability. The key element here, and I think what you're saying is, that correlation probably is much lower than people realize, is the correlation between the value you want to look at and the probability they will report that value given that value. That's for all these samples, the bias is the correlation. The correlation between the probability of response and what they're reporting. So what you're saying is all these opt-in surveys themselves, that correlation actually is quite low.
And the problem is that without having ground truth, it's hard to be able to determine what that is. And the reason why that the survey research community is pushed so hard against things in which we don't have the basic theory is to say, look, most things we don't have a ground truth. If you don't have a statistical theory like you do have a simple random sample or a simple random sample plus some sort of estimation of non-response and coverage error, then how can you ever determine what's bias and what's the variance based off something in which you're trying something totally new and don't have any sort of background information on? And our argument is to say, like, look, that's a problem all over the place, and we're not really sure how much worse these opt-in samples are, or worse or different, as it were, than as far as the tail end of probability sampling is.
But you can take the theory further, right? Because the theory is still the same theory.
Right.
It's these simple random sampling, the probability sampling, just to make that correlation theoretically guaranteed to be zero.
Sure.
In practice, it's not because of the response by everything.
Yes.
But you are showing evidence. Probably some of the research you can devote into studying that the probability people opting, that type of mechanism, how to correlate it, and that give you a base to set up the theory. Moving away from the simple random sample type of theory, but moving to that direction. So all I'm saying is
we should move on. You guys can talk later.
Fair enough.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.